everybody, welcome back to another video from Gyro Ranger, your #1 channel for ethical hacker resources and virtual walkthroughs. Today we're going to be looking at a walkthrough for a box called BrainStorm on TryHackMe. And BrainStorm, it states here that it's reverse engineer a chat program and write a script to exploit a Windows machine. Background on this is that this is a buffer overflow exploit box. And so what we're going to do here is we're going to dive into this one and look at how we can leverage this program to get into this box. Also, if you're enjoying these videos from Gyro Ranger, remember to subscribe and hit that bell so you can become a subscriber to this channel and be notified when new videos are coming out. So let's go ahead and dive into this. So once we start the machine up and we jump into it, the first thing that it asks is how many ports are open on this machine. So let's go ahead and grab our IP address here. And let's go ahead and pull ourselves up a terminal. And let's go ahead and run ourselves a simple nmap here so we can see exactly what is going on with this machine. I like to run it in verbose mode so I can go ahead and see what ports are open immediately as it's running. And immediately I can already see that port 21 FTP is already open on this box. So knowing that information, let's go ahead and try to FTP into this box as the rest of the nmap is running. So let's go ahead and run an FTP on this IP address. And let's go ahead and run a famous anonymous with no password. And let's see what pops up here. And we are in. All right, we are already, as we can see here, we have a Windows NT machine there. And let's see what is in here. So we have a directory called chat server. And let's go ahead and change our directory to chat server and see what is in this directory. All right, so we have chatserver.exe and we have an essfunc.dll file. So let's go ahead and change this to our desktop directory. And let's go ahead and grab these files here so we can go ahead and dive into them. All right, there we go. We have both files here. We've got a chat server exe and we have a DLL. All right, we're still waiting for the nmap to run, so let's go ahead and let that keep running as we dive into this further. Okay, once the nmap is done running and we have both the files on our desktop, next step here is we want to go ahead and dive into this chat server program and see exactly what it's doing. So let's go ahead and clear out our right side here. And let's go ahead and get to our desktop. And let's go ahead and whine this chat server program and see exactly what we get. All right, so it looks like we have a chat server program waiting for connections. And I'm guessing this connection is probably going to deal with this port 9999 that's happening here. So knowing that they have an open port on 9999 and we've already went through the FTP, let's go ahead and kill this over here. And let's go ahead and netcat over to our local program here, or actually the machine. Excuse me. Let's get the IP address for the machine again. And let's go to 9999 and see what we get. And it looks like what we have is a chat beta program called BrainStorm with a username. All right, so if we put our name in, and we get to write a message, we could say, hello, bueno. Gyro Ranger says hello. And if I say hello back, Gyro Ranger says hello. All right. So it seems like we have a basic chat program here. So we need to figure out exactly how we can break this program, possibly using a buffer overflow exploit. So let's go ahead and kill this program. Let's dive into it. Now, to get into this program, I'm going to be using a program called Immunity Debugger, which helps you break down any program down to the machine code level. And I have it on my Kali machine here, running it through Wine. But you could also use this on Windows and download it and run through it. And what I'm going to do is I am going to open up the chat server program on the desktop. And you'll see two things happen when you run this program. You're going to have multiple different windows that are going to open with all of the registers, and also detailing the EIP, which is the pointer to the next command that's going to be coming through the program. And if you have not learned about buffer overflows, or gone through the series on TryHackMe, I would remind you, go back through the 3 different series they have there to teach you buffer overflow. But also, I'm also going to link you to a video that is a very good reference for buffer overflows from another channel on YouTube here that I really enjoyed too. And I think they do a great job explaining what a buffer overflow is. So I'm going to go ahead and hit this little red arrow, which will start the program. And when that happens, you will see that the chat server has started. It's going to wait for a connection. All right, now that we know we're waiting for a connection and it's running on our local machine, we are again going to bring up a terminal, and we are going to netcat actually into our local machine at 9999. Okay, so what I'm going to do here is I'm going to go ahead and try to break the program first with the username section. And on the username section, I'm going to create a certain amount of random characters in a string that I'm going to go ahead and put in. So what I'm going to do is I'm going to print a string of about 2000 GRs for Go to Ranger. And I'm going to take this and I am going to copy this selection, and I'm going to paste it in. And it seems it actually took it and it went to the message. And going back to the Immunity Debugger, it says my username is grgr, about 15, maybe 18 characters there. And so it's immediately going to the next section. Everything's coming through. So obviously it's handling the proper buffers on this command. So now it's waiting for our command. All right. Let's do the same thing, and this time I'm going to put in the same amount for the message. And it doesn't ask me for the next message. So if I go back, we can immediately see that we broke the program. And here's the G, and here's the R, here's the G, and here's the R. And it is paused, which means that we broke the program. Well, that's definitely bad for the program, but that's really great for us. That means there is a buffer overflow possible exploit here that we can work on. So what we're going to do is we're going to dive a little more into here and see how we can leverage this for. So now that we know we have a problem with the message, what we're going to do here is I'm going to go ahead and restart this program. And we're going to open up chat server again. And we're going to go ahead and start this program and see exactly what happens. All right, so we have the connection waiting here. So we know nothing happens with the line. So let's go back into here and let's go ahead and connect back into it. And we will put our name as Geardo Ranger. And on the message, for us to better determine exactly where we are having an issue and where it is overflowing on the buffer, we're going to run a command, Metasploit, that creates us a specific pattern of characters that once we know exactly which characters are sitting in the EIP register, we can compare that in Metasploit, and it'll tell us exactly how many character bytes we have until we overflow the program. And what we're going to do is we're going to run a MSF pattern creation tool here that you can use in Kali Linux. And we're going to go ahead and put, again, 2,500 characters, and we're going to run it. And we're going to take those 2,500 characters, copy it, and let me get rid of that MSF, send it in. We're going to break the program again. And once we come back to Immunity Debugger, we can see we broke the program. Once we've broken the program, we now have the number of 317043330 in the EIP. What we need to determine now is what or if an offset does exist for this program. So we're going to head back over to our terminal, and we are going to run a MSF pattern offset from the 2500 characters with the exact number in the EIP register of 31704330. And running that, immediately it comes back with an exact match of an offset of 2012. That's really good. And now, since we know where the offset is of 2012, 2012, we can move to the next step. So once we know we have the information here of 2012 character bytes offset, let's go ahead and head back over to Immunity Debugger, excuse me. Having some tongue twisters today. And we're going to go ahead and close it again, and we're going to reopen it, and we're going to reopen the chat server program. And once we have the program running, what we're going to do is we're going to come over here and we're going to run Mona modules. And if you don't know what Mona modules are, you should, but make sure you go through the buffer overflow lessons again on TryHackMe to understand this. But what we're going to do is we're going to check the program to see if there are any protections being ran on this program. If you don't mind, I'm going to go ahead and make the font bigger for you to see. There we go. And immediately we can see that there are no protections existing on the essfunc.dll or the chatserver.exe. Perfect. That's exactly what we want to look for so we can move on to the next step. So now that we know that the DLL and the exe file have false all the way through, it was going to allow us to be able to target one of them for the buffer overflow. Now, usually if it would just be an exe file, we would just be targeting the exe. But since we have the DLL file, more than likely we're going to be going after the DLL file on this one. So what we're going to do now is we're going to stay in Mona, but instead of just running the modules, we're going to go ahead and search for the jump commands. And we want to understand exactly where the jump commands are in the program, because once we overflow, we want to be able to leverage those jump commands to take it to a specific exploit command that we drop into this program. So to find this, we do a -s, and we are going to be looking for a XFF XE4. And we're going to be looking in the module of essfunc.dll. Okay, and as you can see here, it says you have a total of 9 pointers. So we have about 9 different jump command locations that are in the program. And so the important thing to do here is take each one of these jump locations and write them down in your notes. And you can go ahead and use them in a program, in the Python program that they're referencing here in the TryHackMe, because it says here, after we're testing for the overflow, determine the EIP offset, which we did. Now that you know you need to find the function, is not know where to check the DLL file, and we need to create a shellcode for MSF Venom. So that's what we're going to go ahead and do next as we move along. So what I've done is I've already taken the time to write a program out here, and I'm going to go ahead and leave a link down in the description of this video of where you can grab this off of my GitHub repository. But I mean, there's a lot of additional little nuances I've written to this, but the basics are still the same. What we have here in the Python program is we have, you know, the remote host that we're trying to attack, the variables for the listening host, what port we're trying to attack, which is 9999, what do we want our custom listening port to be, which is 4444, what do we want our username to be, and then we go into basically some customizations of which Ethernet we're going to be going through. You know, are we doing a local, or are we doing it with ETH0, Tune0 if you're using the TryHackMe network, or if you have a custom IP address, you can put it in there. And then when we get into, we go a little further down, we start getting into the meat of the program, We've already given it all of the different, different variables in there. We've now also made sure we're going to add in a MS Venom Windows shell reverse TCP exploit that we're going to drop into this program using the variable of the listening host and the L port that we add in. And then additionally, further down in, we're going to be adding a certain amount of null characters for NOPs in the program. So if you don't know what a NOP is, make sure, again, you go back and read through the TryHackMe series for buffer overflows, and additionally watch that video from Computer File on buffer overflows. They did a fantastic job of explaining exactly what NOPs are and how you can create what's called a NOP sled, and basically create it a point to once you overflow the buffer, you can then use the jump command to bring you to a certain position in the program and cause your exploit or cause the program to slide towards where exactly your exploit is in the program. And then once that's done, I also provided you the 9 different jump address locations that we got from the Mona modules in Little Indian format for you. So if you're having a problem with one of the jump commands, you can go ahead and hash this one, unhash this one, you can use this location. So I've also made it to where you can use the 9 different locations. And then it will try to connect to the program. And if it doesn't, it'll loop back through if there's any issues and try running through the program again until you have a successful break in the program. So let's go ahead and run this program, and then we'll see if we can't get into the machine. All right, so once we're ready to go ahead and try our test run on this program, we're going to come back over to Immunity Debugger. That is a mouthful today for me, I apologize. And make sure that the program is running. It's waiting for connections. Good, we're good there. And we're going to go open up a terminal, and we're going to come to our desktop. And we are going to run this program using Python 3 and brainstorm.python. And when we run the program, it's going to come up with the custom BrainStorm program text here, and it's going to ask you, are you running on your local network, which Ethernet interface, custom IP of the TryHackMe network. We're running it right now on our computer, so we're going to go ahead and put it on for the local network. It sets the IP address. Please enter the IP address of the machine you wish to attack. It is our local computer, so we're going to go ahead and put the local IP address in. And please enter the port you wish to listen on your machine. We're going to go ahead and with 4444. You can customize this with this program I wrote. And once you run that, it's going to start loading and generating the exploit code for injection. It's going to open up another terminal for you listening on. It's going to try connecting, send the username, send the payload, and bingo, you are in. And as you can see right now, if we do a who am I, this is my local machine, you can see I'm Cali root. All right, so we know we can exploit this machine using the customization of the character offset and the exploit on this machine using MSF Venom. So our next step now is we're going to go ahead and move over to the TryHackMe machine, and we're going to go ahead and run this program again. So just to make sure I remind myself again, I'm going to grab this IP address from the clipboard, and I'm going to come back here. I'm going to kill this program, and I'm going to run it one more time. And we're going to go ahead and go to the TryHackMe network, which is tune 0. What it does is it'll actually read your IP address from your interface. So it'll pull your local IP address and set that for your L host right there. We're going to put the custom IP address in there of the machine we're wishing to attack, which is right there. What is the port you wish to listen on your machine? We're going to go 4444 again. We're going to load. Let the exploit code generate for injection. Sent over, listening on port 4. Connection was successful, sent, and bingo, we are in the machine. And if we run a who am I, we can see we are system on this machine. So all we need to do at this point is we're going to go ahead and get to the users. And let's see who our users are on this machine. And we've got a Drake and a public. So we're going to go ahead and change that over to Drake. We're going to go to their desktop, run a directory on that, and we're going to see we've got a root.txt, and we're going to run a more on the root.txt. And when that pops up, there's your flag. And that will actually finish this box for you. So again, this whole box deals with buffer overflows, exploits, and very simple to do. Again, go through the 3 different series that were on TryHackMe, and also watch that video on Computer File. Get pretty well educated on this box, or on these type of boxes, and it's pretty easy once you understand the steps and you work through those steps one by one to find out where that EIP set is for the character, offset is, the exact amount, and then understanding if you have where the jump commands are, and then creating a proper NOP sled to go ahead and slide that program after you overflow the buffer to that exploit, so you can break open into the machine and get your flag for the capture the flag box. So again, I hope you really enjoyed this video. It's not as long as my other ones. This one's pretty simple up there. I'm going to go ahead and provide you the program through my GitHub repo in the description. Make sure you take a look at that, grab it, fork it, or modify it all you would like for your programs too, for buffer overflow exploits, and be happy if you do that. So with that, we're going to go ahead and close this video. Thank you again for watching from Geardo Ranger, your #1 channel for ethical hacker resources and walkthroughs. And with that, stay safe and stay secure.